Forgot. Sorry. This is static code analysis and secure coding. Could it have saved the Death Star? Oh, my slides are not working. Come on, go. I'm going to have to page down, I guess. There we go. Okay. We're all familiar, or we should be. Oh, it's not showing. My videos aren't showing. Oh, sorry. I thought everybody would be able to see this. Got a video and it's not showing. How do I get it over full screen? No, that's still not showing. That would show. Sorry, technical malfunction here. Nope, it's still going to full screen. Well, we've all seen the video where the Death Star blows up. I was going to show you the video, but it's not working right now. Sorry. You can hear it. It's blowing up right now. That's the normal video with the Death Star blowing up. If we go back to my slide. Oh, go back up. Did I actually go forward? I think I did. Sorry. I am going ahead, and I didn't mean to. Ah! Come on. This is not working very well. Help! Help! I'm having technical difficulties. I'm having technical difficulties with my slides. It's going forward, and I'm not meaning for it to. Too far forward, though? Okay. Sorry. Way too far ahead. Basically, we all know the story. Galen Orso put in flaws into the Death Star. He asked a friend to give those information to the rebels. Part of those rebels, included in those rebels, I should say, was his daughter Jin. She, along with the rebels, usually they were all bad guys, but Jin was just a little bit good. She sent the information off to the rebels and died in the process. Poor Jin. But the rebels used the insider information, and Luke Skywalker blew up the Death Star. We all know that history. But what if the rebels didn't find the information? What if they'd use some kind of tool like static code analysis or secure coding? What if there was some kind of something done that found those flaws? What if they didn't find the weakness and they couldn't blow up the Death Star? What could the history of Star Wars have been instead? So we're going to kind of go a little bit farther and discuss what secure coding is and static code analysis. My biography. Okay, I'm a cyber engineer at Raytheon. I've been there for about 28 years. Not just in cyber, because of course cyber engineering hasn't been around that long. at least not for most of us. I've been a software engineer for almost 25 years. Just recently got a master's degree in cyber engineering, though, and started working in the cyber department at Raytheon, and now work with a couple of my cohorts down there in the middle. And now I'm working on the software side of cyber, helping our groups of all of a lot of them are legacy. We've got a couple new programs though, and trying to help them figure out what secure coding actually means. So a lot of the programs don't understand what secure coding actually means. So that's kind of a new topic for a lot of people. I help them with setting up their secure coding as well as setting up their static code analysis tools. I write a lot of batch scripts. I help them with setting up the tools, and then after the fact, helping them analyze the issues, because a lot of the issues, unfortunately, come out kind of in ways that are a little hard to, let's just say cryptic. I found some the other day that said there were parser errors, and they were just basically coding errors that were very bizarre, let's just say. But we're going to figure those out and help the developers fix their code. They were just bad coding. Basically, we'll go on and discuss what secure coding actually means. Basically, secure coding is the practice of using secure coding principles. Basically, it's the overall interface of secure coding interface between the system and software. And there are cheat sheets. You don't have to understand everything about secure coding. OAuth does have high-level guidances on how to actually write secure code. There's different languages and different secure coding principles for each language. I've included the interface or the URL for each of those cheat sheets. And when I went out to those are pretty good. And then, because if you do use the secure coding principles, it does limit the vulnerabilities that you would find in your code. So that's why we actually recommend that system or software packages and programs use those secure coding principles, because you eliminate coding errors, but you also eliminate the vulnerabilities in your systems. Secure coding risks that could be injected if you do not use secure coding could be injection, broken authentication, broken access control, insecure deserialization. I could go on, but basically you all can read all of these. Sensitive data exposure, all of these buffer overflows. A lot of us are familiar with these titles, but how many of us are actually familiar with what these mean? You will be in just a minute, because I'll give you some ideas and some actual examples. SQL injection. This is an example of a SQL injection. Okay. Using untrusted data in a SQL call. Okay, for right here, they're just calling with customer ID and just calling with ID. If you just modify the SQL ID to say or 1 equals 1, you'll actually get all of the data for every single ID, for every single column, every single table, everything in the database. Very simple change. One command. That's what a SQL injection is. Most people don't understand, but that's just one simple, easy change. SQL injection attacks can make very big differences. In 2008, SQL injection attacks caused $130 million or million credit and debit cards to be affected. They caused Dave & Buster, Office Max, and Barnes & Noble to be affected. 130 million credit cards were hacked. This is an XXE attack. This one is attempting to extract data from a server. All you got to do is pass in this one, etc. password. This one is causing a denial of service because it's passing in a random value that is a file that is an endless file. This one just never ends. All you have to do so that you never have this XXE is make sure that your SOAP frameworks and your SAML files are patched. That way you don't get these XXE attacks. Improper input validation. Oh, this is a fun one. This one you pass in a price, a quantity. Multiply the price times the quantity. You get a total. But say you send in a price that's negative. Guess what happens? The person actually, instead of getting debited, they will get credited. So that's why people should always check for things like this. They should always validate your inputs. These were just some examples. I couldn't include a whole bunch of examples of everything, but these are just some examples of the top 10 for secure coding. Training for secure coding can be found at a whole bunch of different places, but some of these are just some of the top. White Hat Secure Coding, I actually have this certification, by the way. I was one of the first ones to go through this training. White Hat Certified Secure Developer, they offer that training, and that one, when I took it, since I wasn't the first one, maybe that was the only time it was free, but it is free. And it was free when I took it. I'm not sure if it still is. It might still be free. Secure Code Warrior has training, and I think it's free. May only be free for the first 14 days you take it or sign up for it, but they do have free training. And Cybrary has secure coding, but I'm not sure if it's free. You may actually have to sign up for that. Raytheon, we do have Skillsoft training. That one's included in our company. I'm not sure if a lot of other companies offer that or not, but you might be able to get that through your company, and there's an awful lot of those. Yes, sir?
Also, if you have an ACM, Association for Machine Learning.
That's true. ACM does have a lot. I forgot about that one. We used to be able to get that through our company, too. I'm not sure. Yeah, I wasn't sure if, yeah, I forgot about that one because I was able to get that from when I was taking my master's. I forgot about that one. That's awesome. I have to remember to add that to my slide because I'm giving the same presentation for another training later on, a couple more months. This one is a certification you can get from SEI. It's a Certified Secure Developer. Yes, sir?
Can I take a picture of this slide?
Sure, go ahead. This Certified Secure Developer, or excuse me, Certified Secure Professional is only for C and C++. They do also have one for Java, if you want one for Java, but this one's for C and C++. I'm only, right now, most of my programs are C and C++. We do have some Java, but not as much Java. Most of our programs are legacy, so we even have Ada. A lot of Ada. So, yeah, don't laugh. But we do have a lot of Ada. Okay. But yeah, so this is basically the OAuth the CWE top 25. I'm not reading my slide. The top 25 most dangerous. can be found here. And then the OWASP top 10. Of course, the OWASP top 10 are the web application ones. And then the SANS and CWE top 25. Now those, can change as you go. Every so many years, that list does change. And the list that I'm giving in my slide, the OWASP, is the 2017. So that is fairly recent. I think they are coming out with the 2019. I saw a reference to it, but I haven't seen the actual list yet. Most still reference the 2017. Okay, static code analysis. This is what I do a lot of my days, is actually just going through issues. A lot. I mean, like I said, I've got 13 programs, so I'm spending my days going through issues for programs. But basically, static code analysis is running a program or executing the program when it's not really running. So you're just basically building the program and trying to run code or finding flaws when the code is not actually executing. It's not actually doing anything, you're just building it. And so you're trying to find flaws, malicious code, any kind of backdoors. You're trying to find anything that does not follow industry standards. And it's more cost efficient to run it this way because you're finding flaws before it actually gets to earlier in the development cycle. Let's just say that. Because we're finding flaws just as people are putting code into the CM process. So every time we've got it set up so a lot of our programs, anytime they put new code in, a process gets kicked off and they run static code analysis. So that way we're finding issues real time pretty much. So this is a more cost efficient process. Tools can find security issues. Again, buffer overflows, string overflows, SQL injections, hashes, password hashes, cryptos. I've actually found cryptos that are out of date, which shouldn't surprise anybody if we've got legacy code. Syntax related, dead code. Oh, heck yeah, we got a lot of dead code. Unreachable code. I'm finding a lot of that too. We used a lot of different checkers, and we're actually updating with new checkers next week. I can't wait to see what we're going to find next week. But checkers can find software issues being things like this. Uninitialized values, rule violations, memory corruptions, resource leaks, all kinds of things like that. But they can also find cyber issues. That's kind of those security issues we all like to talk about. SQL injection, overflows, secure coding, malicious data. There's a lot of, we use more of the commercial side of the static code analysis, but there are open source tools as well. Tools are available for almost any kind of language you can think of. Like I said, we've got Ada, C. We're going to be having some Androids that hopefully we'll be able to scan soon. And they're kind of interested in us actually scanning some of the Android tools soon. We've got the VB, the XML. I haven't found any of the XML that actually have raised anything yet, but I'm interested in seeing that. And the Visual Basic. I can't wait to see some of what the VB code actually raises. But there's a lot of languages out there and a lot of code that can be brought up. I would love to see some of the COBOL if we actually, I would love to see some, that was my favorite language in college, so I would love to see some COBOL output, but we don't have any at our site, so. This is an example of a static, something you would get from static analysis, like a dead code. This one, it could never become null because this is setting s is equal to null. So it goes into this if statement, and since it's already set s to null, this statement would never be raised. So this is a dead piece of code. It would never be raised. Not null, never is going to get there. It's going to return here, never going to go in here. This part's never going to never be run, because it's always going to go in here and be returned. This is an unchecked error condition. It's this do exchange. This one, it goes into this try do. It says this catch is never going to do anything because it's going to try do, but it's never going to catch this. It's always going to go in here do exchange. This is it's never going to catch this. Always going to do the try, but never going to do the exchange. And then the crypto, because DES has been replaced by AES, these would get caught as risky cryptos in any static code analysis. This is C, this is the Java. So these DES would get caught, and this DES and C would get caught because it's looking for something replaced with an AES. And then this is a buffer overflow. So if you go into this code and it's setting last name to 20, you enter, it's saying enter in a last name. You go into this and you say enter a last name of very, very long last name with underscores between each one. That would be over 24 characters. This would actually cause a buffer overflow because that's 24 characters. It would actually cause the buffer to overflow because it doesn't check for a size. So you have to actually check to make sure that last name is actually going to actually put only 24 in here. It never checks for the size going in there. It's just going to say, okay, give me something. Don't care what, just stick it in there. It never checks. So it's going to cause a buffer overflow if last name is over 20. So, do we have any questions? Yes, sir.
You mentioned that you use some of the commercial or free tools. Can you use them?
Well, we use commercial. We use Coverity for most of our products, the C, C#, C++. We have a lot of different compilers that we use with those, but then we also use CodePeer for the Ada side. Yes, sir.
When you mentioned Android on the slide of the languages you have available, was that referring to the Java source code or the development code? I haven't actually worked with any of the Android devices yet, so I'm not exactly sure what languages those are going to be yet. All they've told me is that it's going to be Android. Okay.
Christy, do you know? It's Java? Okay. Yeah, she's my point of contact for that program, so I don't really know yet. Yes, sir.
How much effort is it to get the static analysis tools compiled in? What you use is not really a bunch of false positives, but
Well, it kind of depends on the tools themselves and what compilers they're using. If it's let me put it this way. If it's a regular compiler like Visual Studio, let me put it that way, and they don't have a lot of legacy code,
Normally it doesn't take me that long to actually get it to work. If they have like regular build scripts and things like that. But if they've got like an out there compiler like Ada Multi, where they've got an off the wall compiler running, and I have to actually go out and try to figure out which compiler is actually being used, because I've had to do that. I've spent days trying to figure out what actually is being built from the command line, because that's what I usually have to do. I have to go and make sure that Coverity is running the right build script, because I have to run from a command line in order to be able to run these builds, create a build script from Coverity. But running from Microsoft is great. I mean, that's no biggie at all. It's just MS Build, and that's from like program files. But some of these other ones are way out there, and it's taken me a while on some of them to do it, but I've been able to, it's getting better. Let's just put it that way. But Microsoft is easy. Those are very easy to set up usually. It's just, build, analyze, commit, and you just need 3 scripts. And then checkers are awesome. They're not that hard to figure out either. So, next slide. So, back to the initial question. If the Empire had used a secure code or static analysis tool, what would the outcome of the movies have been different? Could the insider threat have been left in the Death Star, and would the rebels have been found out, and would the Death Star have been blown up? So does anybody think that it would have been any different, or, what's your idea? Does anybody have any opinions? They needed a different project manager. Come on, guys. Would my lightsaber have been green or red? Come on. Okay.
The Death Star had 100 times as many fighters as they actually launched. If they had used static practices, they would have fixed the main issue, launched 0 fighters, and the rebels would have found some other ridiculous method.
Okay, so you're... It would have still mostly been dead. Okay, so we still would have had a green. Okay.
Well, going to another flaw, they still allowed a robot to plug into a data port.
Okay, we're completely off topic. Okay, I think I've lost them all. Okay. Okay. I think we are done. Thank you. There's my resource. Thank you very much.